Now if you check the Show Regression Line box in the applet, it will show you the line that makes the sum of the squared residuals as small as possible. Now what I would recommend is that you uncheck the Show Movable Line and the Show Residuals and the Squared Residuals and recheck them over under the Show Regression Line area. So I have a screenshot here. Again, I would get rid of this stuff and just check the Show Regression Line, the Show Residuals, and the Show Squared Residuals. So the regression line equation, it asks us to write it here, is 38.3 plus 1.03 times foot length. So that's what we call the regression line. Sometimes you'll see it called the least squares regression line, again because we minimize, made as least as small as possible, the sum of those square areas. And they mention here about putting the caret, the hat over the y variable to indicate that we're getting a predicted height. Now the answer to part B here is yes. So there's only one line equation that will minimize, make as small as possible those squared residual sum. Okay. Now, what you're used to from algebra class is a line being called y equals mx plus b. The thing that you have to be careful of in statistics is, first of all, the y has a hat on it. Second of all, the line equation is written in the opposite order. In other words, the constant or vertical intercept comes first, followed by the slope times the explanatory variable. And second of all, the slope is b, not m. A is the y-intercept, not b. Okay, so again, this is a potential place where you could get confused because you've had ingrained in you from a very early age y equals mx plus b, and now you have to twist your brain a little bit and realize that in statistics y hat equals a plus bx. A is the vertical intercept, b is the slope. Okay, so it's not the same mx plus b that you had before. I mean, it's still the equation of a line, but the symbols have different meaning. Okay, so the slope is 1.03. That's the number in front of the explanatory variable, which is foot length. By the way, I don't know if you noticed, they mention that they've used the variable names in the equation, so we don't actually use just x and y typically. It's nice, right, that we actually use the word height and the word foot length so we know exactly what we're talking about with the equation. Okay, so the slope is 1.03, which is positive. And as it should, this matches the positive direction of the association. So hopefully, again, you remember from your algebra days that when the slope of a line is positive, that means the points go up from left to right. That is what we mean when we have a positive association. If the slope were negative, then the line would go down from left to right, which is what we were talking about when we have a negative direction of our association. So the sign of the correlation coefficient and the slope of the regression line have to match. They have the same sign. They're not the same number. Got to be really careful about that. Right? The correlation coefficient number in this case was 0.7, while the slope is 1. They don't have the same number, but they're always either both positive or both negative. Okay, so let's investigate the meaning of the slope. 9a says, use the least squares regression line to predict the height of someone whose foot length is 28 centimeters. So again, we have that predicted height, and it's predicted when we put the hat on it. is 38.3 plus 1.03 times foot length. What we're going to do, and again this should be familiar from algebra class, we're going to substitute in a 28 for foot length, that's 28 centimeters, and do the calculation. So again, I highly, strongly recommend that you do this calculation for yourself. You can do one step at a time. First I'm going to multiply 1.03 times 28, and I get 28.84. And then when I add 28.84 plus 38.3, I get 67.14. So a person whose foot is 28 centimeters long is predicted to be 67.14 inches tall. That's what this is saying. Okay, then part B, use the least squares regression line to predict the height of someone whose foot length is 29 centimeters. And then part C, by how much do your predictions differ? In other words, subtract them. So I'm going to stop this video here and ask you to complete those for yourself, and then go to the next video and see how you did.